In Unit 8, we're going to be talking about trigonometry, which is the study of triangles. And you probably have heard of some of these terms that we're going to be talking about before in geometry class, and now we're going to take it a little bit further. So we're going to talk about trigonometry with right triangles, and we have 6 trigonometric ratios that we're going to be using this unit. You've already heard of 3 of them when you took geometry class. So if we have a right triangle, and we're talking about this angle, the side that doesn't touch that angle is always the opposite side. O for opposite. The side across from the 90-degree angle, so this box right here, the side that doesn't touch that is always the hypotenuse, abbreviated H, and the remaining side is your adjacent side. So I always like to label the hypotenuse and opposite side first because to me those are easier, and then the remaining side must be the adjacent. So sine, cosine, and tangent should be familiar from last year. The sine is the opposite, the ratio of the opposite over hypotenuse. So opposite over hypotenuse. Cosine is the ratio of the adjacent over hypotenuse. And the tangent is the ratio of the opposite over adjacent. We used to write out last year SOHCAHTOA for solving these problems. That's still going to come back and make it useful for us. Now we have 3 new ratios. This one is called cosecant, and the cosecant is 1 over sine or the hypotenuse over the opposite side. So it is sine flipped, or 1 over sine. SEC stands for secant. That is 1 over cosine, or hypotenuse over adjacent. And then you probably guessed it, cotangent is 1 over tangent, or the adjacent over the opposite side. And again, either one of those will work, and sometimes it'll be more useful to say 1 over tangent. Other times it'll be more useful to say adjacent over opposite, but it doesn't matter which one that you use. So down here we're going to evaluate the 6 trigonometric functions for this angle theta. So the hypotenuse is already labeled for us. It's across from the box, but we don't know how long that is. So we got to do 8 squared plus 15 squared equals c squared, because that's the Pythagorean Theorem. 64 plus 225 equals c squared. So we get 289 equals c squared. And when you square root both sides, we get 17 equals c. So our hypotenuse is 17. Now the opposite side doesn't touch our angle, so over here this 8 is the opposite side. And then that makes this 15 the adjacent. So now let's do the sine of theta. Sine is opposite over hypotenuse, so 8 over 17. And then I like to do cosecant next, because I know that is just sine flipped. So 17 over 8. Cosine of theta is, cosine is adjacent over hypotenuse. And then secant is cosine flipped. And then finally we have the tangent of theta. Tangent is opposite over adjacent. So then cotangent will be the adjacent over opposite, or tangent flipped. So those are your 6 trig ratios. Very easy to come up with once you have your triangle labeled with the opposite, adjacent, and hypotenuse. Example 2 here says if theta is an acute angle of a right triangle and cosine is 3/8, what is the value of cotangent? So what I want to do is draw a right triangle, and it doesn't matter what angle you choose. Let's just choose this one. And it says the cosine is 3/8. Remember, cosine is the adjacent over hypotenuse. So if this is equal to 3/8, that means my hypotenuse is 8. Hypotenuse doesn't touch the box. My adjacent side, well, what side is the adjacent? I know that this is the opposite side, which then makes this the adjacent side. We know the adjacent is 3. Okay, now cotangent, up here, cotangent is 1/tangent, or the adjacent over opposite side. So we need to figure out what the opposite side is using Pythagorean Theorem. So we have 3 squared plus, we don't know what the opposite side is, so x squared equals, well, we know what the hypotenuse is, it is 8. So then we can solve this. We have 9 equals x, this should be a plus. 9 plus x squared equals 64. Subtract 9 from both sides, and we get x squared equals 55. And when we square root that, we have to make sure we don't want decimals. So we have to make sure that we can't simplify the radical. So square root of 55, x equals, well, can we break up 55 into perfect squares? If I take 55 and divide it by 9, that's not a whole number. 55 divided by 4, 55 divided by 16, 55 divided by 25. So we don't get a whole number, so we're going to leave this as a square root of 55. That is something that is going to be challenging this unit, is that we don't usually want to get a decimal approximation unless the problem asks for it. We want exact values, so we're going to leave it as a square root of 55. So cotangent is the adjacent side over the opposite side. So that's going to be 3 over the square root of 55. But we can't have a square root in the denominator, so we have to rationalize that, which means we're going to multiply the top and bottom by the square root of 55. Okay, so the top will simplify to 3 times the square root of 55, and then the denominator will just be 55. And then if we can we do 3 divided, can 55 and 3 be simplified? No. Because if we could simplify this right here, 3 over 55, we would want to. But since we can't, then this is our final answer. We must rationalize all denominators if we have a radical in there. All right, over here, I want you to try this on your own. So I can get you started a little bit. Okay, there's theta, which makes this the opposite, hypotenuse, and adjacent. And we know that cosine is 7/10. So that means that the adjacent side over hypotenuse, because that's cosine, So we know that the adjacent side is 7 and the hypotenuse is 10. So go ahead and calculate the opposite side using Pythagorean Theorem and then find the value of sine. All right, so you can see my work here. We had to use Pythagorean Theorem to get that the opposite side was a square root of 51. We can't simplify that radical, so we leave it alone. And then the sine is the opposite over hypotenuse, so the square root of 51 over 10. Now, we don't need to rationalize anything because our denominator is a whole number already. So that means this is our final answer. All right, on this page, what we're going to do is find the sine, cosine tangent, cosecant, secant, and cotangent of all the angles. So we're going to do this for 30 degrees, 60 degrees, and 45 degrees. You know, this triangle has two 45-degree angles, so we don't need to do it for both, but all three of these angles. And when we do that, we have to make sure to reduce fractions and rationalize the denominators. So we'll start with angle 30. So if 30 is my angle, and we have our right angles here, this is the hypotenuse, this is the opposite side, and this is the adjacent. So then the sine of 30 degrees is going to be the opposite, 5 over hypotenuse, which is 10, and that simplifies to 1/2. The cosine of 30 degrees, that is going to be the adjacent 5 times the square root of 3 over 10. We can simplify 5 over 10 to 1 over 2. So this is really going to be 1 times the square root of 3 over 2, or just the square root of 3 over 2. And then tangent of 30, the tangent of 30 is going to be the opposite over adjacent. So 5 over 5 times the square root of 3. Well, the 5's on top and bottom are going to cancel or reduce, so it's going to be 1 over the square root of 3, but we can't have the square root of 3 in the denominator, so we're going to multiply the top and bottom by the square root of 3, and this is going to give us the square root of 3 over 3. So that's the sine, cosine, and tangent of 30 degrees reduced. So down here we have a table. Let's fill in those values. So the sine of 30 was 1/2. The cosine of 30 was the square root of 3 over 2. And the tangent was the square root of 3 over 3. Now cosecant, secant, and cotangent. We could do it either way. We could take the sine, cosine, and tangent and flip them, or we can go back up to the original triangle and do the reciprocal side. Either way is okay. So let's do the cosecant of 30 degrees. Well, that's going to be either 1 over sine or the hypotenuse over the opposite side. So 10 over 5, which simplifies to 2. The secant of 30 degrees, that's going to be the hypotenuse over the adjacent side. 10 over 5 times the square root of 3. Well, 10 over 5 can be reduced to 2 over the square root of 3. And then we have to multiply the top and bottom by the square root of 3. So we get 2 times the square root of 3 over 3. So it's very important that you guys understand rationalizing the denominator and simplifying your fractions. And then finally, cotangent of 30 degrees, that's going to be 5 times the square root of 3 over 5, because cotangent is the adjacent over the opposite side. So that is going to be, the 5's will cancel, and we're just left with the square root of 3. So let's fill that in down here as well. So cosecant was 2. Secant was 2 times the square root of 3 over 3. And cotangent was just the square root of 3. So I know the table goes to 45 degrees next, but I want to do 60 degrees while we're still in this triangle over here. So now our angle is going to be focused on 60 degrees. What that means is that our opposite and adjacent have flipped. And once we start doing a couple of the sine, cosine, and tangents of 30 degrees, you're going to see a pattern develop. And that's going to make things a bit easier for us later on. So I'm actually going to do the 30-degree ones up here, since I'm running out of, 60-degree ones, because I'm running out of room down here. So the sine of 60 degrees, well, sine is the opposite over hypotenuse. So 5 times the square root of 3 over 10. Well, 5 over 10 reduces to 1/2. So this is going to be 1 square root of 3 over 2, or the square root of 3 over 2. Cosine of 60 degrees. Cosine is the adjacent over hypotenuse, so 5 over 10, which simplifies to 1/2. And then tangent of 60 degrees. Tangent is the opposite over adjacent, so 5 square root of 3 over 5, which simplifies, the 5's cancel, and we're just up to the square root of 3. So let's go down to our table and fill this in for 60 degrees. So the sine of 60 degrees was the square root of 3 over 2. The cosine was 1/2, and the tangent was the square root of 3. So let's look right here and see if we could figure out a pattern. Look at 1/2, 1/2. Square root of 3 over 2, square root of 3 over 2. Look, and then look at the tangent of 60 and the cotangent of 30. So based off of that, we could say, well, if the tangents and cotangents flip, we could just take tangent of 30, and that's going to be the cotangent of 60 degrees. And you see how the sine of 30 and the cosine of 60 are the same? That means that the cosecant of 30 and the secant of 60 should also be the same. And similarly with the secant of 30 and the cosecant of 60 will also be the same. And we could go up here and verify that very quickly. Like if we wanted to do, the secant of 60, okay, secant is going to be the hypotenuse over adjacent. And we'll just do that last one. The secant of 30 degrees is 10 over 5, or 2, which is what we got down here when we did the matching. So you're going to see patterns in these values here. So that's the 6 trig ratio for 30 degrees and 60 degrees. And because we reduced the fraction, that works with any triangle, not just the specific one that we have drawn here. So over here with 45, what I want you guys to do is to try this. The sine of 45 degrees. Now you may say, well, which 45 degrees do I use? Well, it doesn't matter, because you see the other side, these sides are both 6. So I'll use this one here, and that makes this the adjacent. You're going to have to probably do a little bit more rationalizing of the denominator here, but that's okay. So go ahead and try to come up with the 6 trig ratios for 45 degrees for this angle right here. Pause the video, and when you're done, we'll talk about it. All right, the neat thing about 45 degrees, if we look at this triangle, the opposite side and adjacent side are the same thing. So when we calculate sine and cosine, the hypotenuse is 6 times the square root of 2 in both cases, and the opposite and adjacent side are also both 6, so they actually will equal the same thing. So I simplified and got 1 over the square root of 2, but then rationalizing the denominator gets you square root of 2 over 2 for both of them. Now the tangent, opposite over adjacent, well, that's 6 over 6, or 1. The cosecant, that's going to be the hypotenuse over the opposite side. You have 6 square root of 2 over 6. Those 6's will cancel, and you're left with the square root of 2. The same thing with secant. And then cotangent, well, 6 over 6 is still 1. So let's write those in this table down below. All right, so you really need to memorize these things, and I know that seems like a lot right now, but if you recognize the patterns, it becomes a lot easier. And in all honesty, all you really have to memorize are these values, and then you can derive everything else, because if you know the sine, you know the cosecant, you can just flip sine. If you know the cosine, you can get the secant, you can flip cosine. To calculate tangent, remember tangent is, you could do sine over cosine, and that will give you your tangent. And then once you know tangent, you could calculate cotangent. So these are the only ones that you absolutely have to memorize, but you also will then need to memorize, how do I go from sine and cosine to get tangent, cosecant, secant, and cotangent. And we're going to be doing a lot of practice from now on with these values. So thanks for watching the video. Make sure to like it and subscribe. Now a new one for tangent that is going to be added to us is now sine over cosine. So that's another way to calculate tangent. If we know the sine and cosine, we can just put those in a fraction and simplify it to calculate tangent. Now the new ones, cosecant is 1 over sine, or the hypotenuse over the opposite. And secant is 1 over cosine, or the hypotenuse over the adjacent. And then cotangent is 1 over tangent, or the adjacent over hypotenuse, or cosine over sine. So any of those ones will work.